Hello everyone, welcome back to another SATs preparation video. Now, in the last few days, we have released 3 different videos. We looked at reading comprehension, we looked at maths techniques, and we looked at how to answer 2 and 3 mark questions. So today, what I thought we'd do is dive into some of the trickiest reasoning paper questions that have come up in the last few years, let you have a go, and I'm going to talk you through exactly how to answer them so you get that practice in before the real thing. So let's dive straight in. 3 pineapples cost the same as 2 mangoes. 1 mango costs £1.35. So at any point you can pause the video and have a go. I'm going to dive straight in because the question is, how much does 1 pineapple cost? So the first thing to do, I like to draw pictures, and this is something I tell you guys to do as much as possible. Look at this huge gap here. Use it. So we know that 2 mangoes, so I'm going to draw a bar model just to represent 2 mangoes, split in half there, is the same cost as 3 pineapples. So I'm going to draw a bar underneath. That is the exact same length to represent that it being the same cost. However, there are 3 pineapples, so these parts are going to be smaller. So we know that 3 pineapples, I'll put P for pineapples and M for mango. How much does 1 pineapple cost? So we actually want to figure out this amount here. How much is 1 pineapple? And now drawing these pictures help us to answer the question because we can label the information we've got. 1 mango costs £1.35. So we can put £1.35 here. And we know then if 1 mango costs £1.35, so does the other one. And here's how we unlock this question. We know now that the total of 2 mangoes is £1.35. And you could be writing this in the box to show you're working out, just like we discussed yesterday. Go and watch that video if you haven't, how to answer 2 and 3 mark questions. £1.35 plus £1.35. We're just going to make sure we get this right. You might be able to double this in your head, but I'm going to just make sure using column method, we get £2.70. Why is that important? Well, we know now that the total of the mangoes is £2.70, which means we also know the total, that's right, for the 3 pineapples is £2.70 because we got that from the first sentence, costs the same. So now that we know that 3 pineapples cost £2.70, how are we going to work out 1? Well, it's a simple case now of short division. Now you might notice straight away that 27 is in the 3 times table. So you might notice that that's going to be 9 times 3. So the answer would be 90 pence. If you weren't sure, you could still whack it into the bus stop method just like this. Decimals don't matter. Just put a decimal at the top. Divide it by 3. How many 3's in 2? There are none, but we still have that 2 left over. 3's into 27, like we just discussed, is 9, and then 0 at the end for the placeholder. We have 0.90 pence. You just have to be so careful. When you write your answer down, there'll be a little box down here. Make sure that is the worst box I've ever drawn. Make sure when you put your answer in the box, you remember any units. In this case, £4, we'd have to put 0.90. Or you could write 90 pence. Just be aware of units. Okay, you must get that right. So tricky question there, but top tip for answering these questions, draw. That's what the gaps are there for. Any representations you want. But just remember, like I said in the video yesterday with 2 and 3 mark questions, this isn't working out. You need to show your formal methods. Therefore, if you make 1 mistake, you can still get 1 mark. Let's try another one. We've got a really wide range of questions here for you to practice before the real thing. So like I said, pause the video at any point, have a go. I'm going to dive straight in. A square tile measures 20 centimeters by 20 centimeters. I like to just label things, guys. I'm going to put 20 centimeters here. I know it's a square, so I know each side is 20 centimeters. A rectangular tile is 3 centimeters longer and 2 centimeters narrower. And you'll notice here that we are testing your vocabulary. I'm sure all of you are very confident in understanding what longer means. We're going to add on to the amount. So this length here is not 20, it's going to be 23 centimeters. But narrower is one of those things that just can trip us out, and we don't use it that often. We think, oh, what does it mean? Well, guys, now you know, because I'm going to tell you. Narrower is the opposite of wider. So it's the same idea as getting smaller. If something is narrow, like a narrow alley, you might have to squeeze through to get down there. So narrower is smaller, which means we take off 2 centimeters. So again, instead of being 20, we're going to go 2 less than 20, which is 18 centimeters. Now that is only the very start of the question. We have done no working out. That's why reasoning questions are really tricky, because we have to actually work out what we've got to do first before we even do it. So that is my number 1 tip. Jot things down, write them down. Let's look at the actual question now, which is in this kind of grayish blue box. What is the difference in area between the 2 tiles? So To find out the area of a rectangle or a square, which is a type of rectangle, we have to multiply the base times the height. So for the square, we have 20 multiplied by 20, and we can use our times table facts here. We can do 2 times 2 is 4, and then we have 2 placeholders to make it 100 times bigger. So that's 400 centimeters squared. Nowhere near finished. If we stopped now, we'd get 0 marks out of 2. Now we need to figure out the area of this shape. So we're going to do 23 multiplied by 18. Now guys, lots of ways to do this. You might have some mental strategies. I'm going to write it out as long multiplication just to make sure I get this right. 8 multiplied by 3 is 24. 8 times 2 is 16, plus 2 is 18. So 184 on the top. And then underneath, we're going to multiply by 10, put a placeholder in, and now it's just one lot of 3, one lot of 2, and we find the total. So the answer here, 8 plus 3 is 11, and we have 4 there, so 414 centimeters cubed? We're not talking about volume, centimeters squared. If we stopped there, we're really risking getting 0 marks still because we have to finish it off. The final piece here is finding the difference. Another tricky vocab word because it's just classic. You might be thinking, that's not tricky. Yeah, but if you know what difference means, of course it's easy. But if you just get muddled up and confused, it can be quite tricky to remember under the pressure of a test. Finding the difference between two numbers is going to involve subtraction. So we have to do 414, and we're going to subtract 400. Luckily for us, that is a really simple question. We're going to be left with 14 centimeters squared. That is the difference in area. Look at this again. Take notes, jot things down. It's extra to the working out. That's my number one top tip. When you're figuring out what to do, draw things. Then at the bottom, do your maths, do your calculating. Next question. Have a go if you want to. Pause the video. If not, you can watch me talk it through you and prepare you for this reasoning test. Cube A and cuboid B have the same volume. Now, we talked about area, multiplying base times height. To work out the volume of a shape, we do base times height times depth. We add that third dimension in. So what is the, calculate the missing length of cuboid B. So we know these are equal. Now, we can't obviously work out what that missing length is yet. The reason is because we don't know the volume. However, we can work backwards. So what we do know about a cube is that every single edge on a cube measures the same distance. So here we have a width, a depth, and a height. All of them are 6 centimeters. So to start off, let's figure out the volume of this shape, because once we have the volume of this shape, it's the same for this one. So here we have 6 multiplied by 6 multiplied by 6. If we work it out, we get 36 is 6 times 6. And then when we do 36 times 6, just write it out, guys. Make sure you're going to get this question right. 6 6 is a 36, 6 3 is a 18, add the 3 is 216. So we know the volume of this shape is 216 centimeters cubed. Now, let's fill in the information we have and see what the question is. So we have 6 centimeters for the depth, we have 4 centimeters for the height, and we have something for the width equals 216. So next thing we want to do is figure out, okay, what is 6 times 4? 6 times 4 is 24, multiplied by blank is 216. Now, if we are super confident with our chunking, we can figure this out mentally now, because if we put in a 10 here, let's pretend it's a 10 for a second. 24 times 10 is 240. So 10 lots of 24 is 240. Well, we don't want 240. We want 24 less. So we need to take off one lot of 24. One lot of 24 off 10 lots goes to 9 lots. And if you wanted to check that out, guys, you could do 24 multiplied by 9 and check to see if you get 216. The other way we could do this, I'm going to show you a really quick shortcut. We know here that 6 times 6 times 6, which is the volume of shape A, is the same as 6 times 4 times blank. Now, we can balance equations and use logic here to figure out what the missing side is. Because if we think about it, these 6's here cancel each other out. So let's get rid of those 6's. So what we're saying here is 6 times 6 is the same as 4 times what? Well, we know 6 times 6 is 36. How do we make 36 over here? 4 times blank? That's right, it's 9. So we do have shortcuts in these questions, okay? They are there if we are confident. But here's my other top tip. Look for them if you feel that confident in these types of questions. But if not, show every single step. Label things. Jot things down. Write it down. The more you try and keep in your head, the more flustered you might get. You might forget a number, make a small mistake. I promise you, writing these things down is going to be massively help you in this test. Here's another one. In this diagram, remember, have a go at home if you want, then I'll talk you through it. The shaded rectangles are all equal width. So all of these rectangles here with W are equal width. Calculate the width of one shaded rectangle. Now, what we need to do here is a bit of spatial reasoning. We need to imagine being able to move these shapes. So we're going to keep this here. And what we're going to do is imagine moving these rectangular blocks to the end. So for example, this one here, we'll call it A. We're going to move it to the far end over here. So I'm going to draw it out again by the side. We're also then going to move what I call B all the way over as well. Okay, so we have A and B. These are, we don't know, just W length. That's what we're trying to figure out. And then what's left over will be the two white rectangles. Now I'm going to actually combine them. So 18 centimeters and 9 centimeters. That means altogether we'll have 27 centimeters. So now we've done this, let's just draw underneath. You can see here, not to scale. We'll just draw over that. We're going to draw in the 34 centimeter block, which has one W here. Now this is really interesting because we know that this is 34 centimeters. So how, you might think, can I calculate the width of one of these grey boxes? Well, let's take a look here. We know that this is 34 centimeters. We can cancel out the two on the left. Let's cancel those. And we know that this is 27 centimeters. So to figure out how wide one width of the rectangle is here, we are simply finding the difference between 34 and 27. What do we have to add on to 27 to get up to 34 and make these the same length? Well, we can do that by doing 34, find the difference like we said earlier, subtract 27, not just 7. 14 take 7 is 7, 2 take 2 cancels out. The answer is 7 centimeters. So again, a huge part of this question and in the tricky reasoning questions is visualizing what is going on. If I asked you in your year 6 key stage 2 SATs paper to do 34 take away 27, you'd be laughing. Of course, everyone can do that. The maths is sometimes very easy. The trick comes in drawing out and visualizing the question. Number 1 top tip. Another one. I love this question. And if you like these walkthroughs, guys, we so appreciate you liking the video and sharing it with people you think it might be useful for as well. That's the only plug I'll say. If you subscribe, we'll keep making videos that help you guys. 6 identical right angle triangles are arranged to make a rectangle. And really important for us to know what identical means. It means the exact same. So as soon as we find one thing out about one of the shapes, we can copy it to every other shape that we've got. So 6 identical triangles are arranged to make a rectangle. Calculate the length of this rectangle. We need to know this here. So straight away, you might be looking at this going, how on earth can I do this? Well, let's just dive deeper and take a look. We need to know this side of one of the triangles, one of the long sides going up. And we also need to know one of the short sides at the bottom. So straight away, you need to be thinking, okay, how on earth can I do this? I'm going to tell you one thing immediately. We are given this as 7 centimeters. Now, in these questions, when you're given something, it's for a reason. You're going to have to use this fact to solve this question. Now, what I want you to realize is this length here is 7 centimeters. So if we cast our eye across, follow my pen, what do we know about this length? Well, obviously, that's also 7 centimeters. Now, this is really powerful because then we know every single length of every single triangle is the same because they are identical. So this long edge down here is the same as this length down here. That's why the question told us they are identical. So I actually know that this length is 7 centimeters. But that's only half the question because I also need to figure out what's the short edge. Where on our rectangle in our picture can we see a short edge or maybe 2 short edges next to a given measurement? Have you found it? It's right here. Look at this. We have one short edge and another short edge. So here we have 2 short edges equals 7 centimeters. So if we half that, we get 3.5 centimeters for each of the short sides. That means this is 3.5 centimeters. And now we've done all of that calculating, that problem solving, that reasoning. We can just combine them. So we're going to do 7 plus 3.5. If I could draw a 5 properly, it would be very good, wouldn't it? And we get 10.5 centimeters. Again, this is not hard maths. Why is the reasoning paper so tricky? Because we have lots of problem solving and working out of what to do on our own in a test condition. Draw out as much as you possibly can. I sound like a broken record. I've said it about 57 times at this point, but I promise you it's so important. Next question. These are tricky. If anything, they're getting trickier. ABDE is a rectangle on a coordinate axis, plural of axis. So ABDE is just called that because that's the name of each of the corners of the shape. The sides of the rectangle are parallel to the axes. So we know that this line is parallel to the y-axis, and we know that ED is parallel to the x-axis. That's going to be important information. Let's have a look down here. Point C is the center of this rectangle, is the absolute center of this rectangle. What are the coordinates of B and D? So we need to figure this out. It might look at first like this is the most ridiculous question you've ever seen, but let's see what we know. We go straight to the picture and we label down any facts that we know already. For example, I know how to read coordinates, and at this point, you guys should be confident doing that too. 25, 30. That means that A, we went 25 across, so this is 25. We can label that information. And we went 30 up the y-axis, so this here is 30. That is so powerful already, because we know then for a fact that in terms of B, it is height 30. So we know we go across something and then up 30. So straight away, I can write 30 as the height of the y-axis for point B. Now let's keep going. We know this is 25 and this is 30. And the really important point now to unlock this question is C. C is the center, is the middle of the rectangle. So again, we know we went 40 across. So this here is 40. So I'm going to just stop right there for a minute. And I'm going to now tell you that because we know this is 40, we also know what the end of the rectangle will be, what value that is. So the start of the rectangle is 25, the center is 40. So we need to do whatever this jump was here, we need to do the exact same jump again to get this value. So 25 to 40 is a jump of 15. We need to do the same jump again because it's bang in the middle. So 40 plus 15 is 55. So for D and B, we've figured out the X value of the coordinate. We go 55 across. So we've already solved B now. It's 55 across and 30 up. This is 55 across. The last thing we've got to do is figure out, okay, what did we get up to in terms of the y-axis for D? And it's the same logic as before. Here, we know it's 22 high, halfway up the rectangle. So let's label this as 22. And we know now that this jump is the same as this jump. So 30 to 22 is minus 8. So we have to take off another 8 to get down to the right height for D. 22 subtract 8, or I'm going to write it in the right place, is 14. We can therefore write down 55, 14. So this question is not about reading scales and coordinates. It's taking it to the next level. Once you understand what coordinates are and how you read them, you've got to work backwards because you were given the coordinates. You had to label them on the chart. Guys, I can't stress this enough. I am a literal teacher of maths of this curriculum. Look at all of my working out on this piece of paper. So you might be thinking, oh, if you're really good at maths, you just do it in your head. I promise you that is not the right thing to think. This is how we make sure we get the answer right every time. We jot down our working out and we show our thoughts on paper. Then we can organize them and get the right answer. So here we'd have 2 coordinates and we'd get every single mark. Here is the last question. It's a really interesting one. Adam has this rectangular piece of card and it's marked with grid lines. Adam makes 2 straight cuts along the grid lines. So only 2 cuts. I'm going to underline it because it's important information. The 2 cuts divide the rectangle into 3 shapes. 2 squares of different size and 1 rectangle. Now, of course, a square is a type of rectangle, but when it's saying here 1 rectangle, it means with a different width or a different height. Using the grid lines, draw 2 lines to show where Adam could have made his cuts. This is essentially a question that is testing your spatial reasoning. Because this, you could use trial and improvement. There is not a set way to get this right every single time. Okay, but the really important thing is you only have 2 straight cuts. So with your first cut, you need to think, okay, I've only got 2 cuts. So with my first cut, I have to meet one of the criteria. I have to create something because I need to make 3 different shapes. So I can't waste a cut. So I'm going to make a square with my first cut. I'm going to cut down and I'm going to make a square. Now, what I noticed straight away is the length of this height here, let's call it, is 5 squares. So I'm going to use that as one side of my square. And that means I'm going to go across 1, 2, 3, 4, 5. That means if I make a cut right here, that's 1 cut and I haven't wasted it because I've made, let's do a tick box over here. I need a square, I need a square, and I need a rectangle. So with my first cut, no wasted cuts, I've made a square. A 5 by 5 square. I'm going to label it S. You don't need to do that in a real thing, but just so you can see it, that's my first square. Now I've only got 1 cut left. So I've made 1 cut. I've got 1 more cut to do. With this cut, I need to make another square. And then whatever's left over is hopefully a rectangle. So again, look at what you've already got. This is too wide. So to make a square, I need to go too high. Now I know I can make a square here. I'm going to draw it in. This is square 1. This is square 2. And this is where we really do think, cross our fingers, have we left a rectangle? Yes is the answer. Look, 2 across, 3 down. That is my number 1 rectangle. So the biggest hint for this one is read the question carefully. You only had 2 cuts. Don't waste a cut. At least start making them as you go. Trial and improvement. If it didn't work, grab your rubber, rub it out, try again. But this question is a question that could have eaten a lot of time if you got confused. So it leaves me with my final tip, guys. If you get really stuck on a reasoning question in the reasoning paper, move on to the next one, because your next one might be something you're really good at. But that was a compilation of some of the trickiest reasoning questions, and I hope me going through them with you is preparing you really nicely for the real thing. So guys, give us a like, share the video, and thank you so much for watching. I'll see you again soon.